We're solving a system of equations for Module 6. Please make sure that you know the methods to solving a system of equations. Two of the methods are substitution and elimination, which we'll go over today. So steps for substitution, I'm going to follow along with my given system here. We're going to isolate a variable, meaning X needs to be by itself or Y needs to be by itself in one of the equations. If not, we're going to make sure that we isolate a variable. We'll move one thing from one side to the other side of the equal sign to get a variable by itself. But if you'll note, the first equation already does that. So we already have in our first equation a variable by itself. It says y equals -5. So I'm going to label this equation 1, equation 2. So after we have step 1, which we've already gotten, substitute the variable's value into the other equation. So since I know that y equals -5 in the first equation, I'm going to take this second equation, which is 5x plus 4y equals -20, and substitute that value in. So I know that y equals -5. So I'm going to bring down everything else, and I'm going to replace the y with -5. From here, I'm just going to solve. So I have 4 times -5, which is -20, equals -20. My goal here is to just isolate x. It's to solve for x. X is on the left side of the equal sign. I need to get rid of that -20 and that times 5. Always get rid of adding and subtracting first. So I'm going to add 20 to both sides of the equal sign. So I get 5x equals -20 plus 20. Well, that gives me 0. And then finally, to get x by itself, it's being multiplied to 5. So I'm going to divide both sides by 5. 0 divided by anything, including 5, is just going to give you 0. So x equals to 0. And then how do I find what y equals to? Well, remember in the first equation, they already told you what y equals to. Y equals to -5. So your final answer, which should always be a coordinate point, is 0, -5, x, y. And now for substitution, the steps are a little different. First off, you would like to have the equations line up with each other. So if you look at the equation given to you in number 2, equation 1 and 2, they're already lined up with each other, meaning the x's are lined up together, the y's are lined up after the operation, and after the equal sign, the constants are lined up. So this is how we want it to be. If not, we'll move it around so that the variables line up with one another as well as the constants. So step 1 is already done. From here, we're going to isolate one variable by making their coefficients the same number but opposite signs. So keep that in mind, same number, opposite signs. It really doesn't matter which variable you decide to get rid of first. It could be x, it could be y. You're all going to end up with the same answer in the end anyway. So I'm going to go for the x value. In front of the x here in the first equation is just going to be 1. So 1 and 2, I want them to be the same number. Well, how can I make them the same number? What could I multiply by? I could multiply the 1 by 2. I not only want it to be the same number, but I want it to be the opposite sign. So I'm not just going to multiply this by 2, I'm going to multiply it by -2. But make sure you keep it balanced. So meaning whatever you do to this first equation for x, you're going to do to everything in the first equation. So if I distribute -2 into everything in the first equation, it will state -2x, -2 times 7y is -14y equals 0. Now I don't need to do anything to my second equation because I already have exactly what I need for the second step. If I bring down the second equation and I look at the variables for x, they're the same number, they're both 2, but opposite signs. Why is that important? Because when I combine them, -2 plus 2 will give me 0, meaning I can get rid of it and just solve for y from here. So from here, negative 14y minus 8y would give me negative 22y equals 0 plus 22 is 22. To solve for y, it's being multiplied to negative 22, so I'm going to divide negative 22 on both sides, and I'll get y equals negative 1. So what do I do to solve for the second variable? Look at step 4. To solve for the second variable, you plug in the value of the first variable. Doesn't matter where you plug it into. You can plug it into the first equation, the second equation, or modified equations. It's still going to give you the same answer. So for simplicity's sake, I'm going to just plug in my new y value into the first given equation, which I'm out of room, so I'm going to write up here. So if I write x plus 7y equals 0, which was the original first equation I was given, and I replace the y with negative 1, I'm going to get x minus 7 equals 0. Solving for x, I'll add 7 to both sides, and I'll get x equals to 7. Now remember, your final answer should be written as a coordinate point. So it'll be x comma y, 7 comma negative 1.